Welcome to the Discover Bittensor podcast. My name is Nick, and the objective of this podcast is very simple: help normal people understand Bittensor. Today's episode is really meant to do one thing. It's meant to inspire you, because when most people first hear about Bittensor, they tend to imagine one very specific thing. They imagine AI models, they imagine chatbots or large language models competing with each other. And yes, that's part of the story. But if you stop there, I think you miss something much bigger, because Bittensor is not just a network for AI in the narrow sense. It is, potentially, a network for organizing digital work more broadly. A network where miners compete to provide something useful. A network where the best output gets rewarded. A network where the economic system is not an afterthought, but part of the design itself. So in this episode, I want to zoom in on 4 subnets that, in my view, help make that broader possibility much more visible. The 4 examples are Bitcast, Hippius, Zeus, and TAO private network. And before we begin, 2 quick disclaimers. First, this is not financial advice. I'm not saying these are good investments. I'm not saying these are the winners. I am not saying these are the subnets that will dominate in 5 years. I simply chose them because I think they are unusually useful examples for understanding what can be built on Bittensor. And second, I personally think that most of today's subnets probably will not exist in a few years. It's just how pioneering ecosystems usually work. Most startups do not make it. Most early experiments fail. Most early internet companies disappeared. Most early crypto projects disappeared. So I think we should be realistic about that. But that does not make the current subnets unimportant. Quite the opposite, actually. These are the pioneers. They are the people going first. They are the experiments that show what is possible, what's not possible, what works, what doesn't work, and which economic models might eventually survive. So even if many of them fail, they still matter immensely, because they are helping define the frontier. And with that in mind, let's start with a quick recap. A subnet is basically a specialized mini economy inside the broader Bittensor network. Each subnet is focused on some specific category of useful work. Inside that subnet, miners compete to produce something valuable. Validators evaluate the quality of that output, and rewards are distributed based on performance. That is the basic shape. So instead of one giant network where everybody does the same thing, like Bitcoin, Bittensor creates many smaller competitive arenas. One subnet might focus on storage, another one on weather prediction, another one on creator marketing, another on image generation or data retrieval. The key idea is that the network is not just rewarding raw computation, it is trying to reward useful outcomes. And every subnet also has its own subnet token, often called its alpha token. That is where the economics become really interesting. Because if you want exposure to a specific subnet, you generally need TAO first. TAO is the base asset of the network, and from there, participants can move into individual subnet tokens. So TAO is like the base layer currency of the overall Bittensor economy, while subnet tokens are more like the economic units of individual sub-economies. Now, why does this matter? Well, subnet tokens are constantly under pressure. Miners have to be paid, emissions go out. And if value does not come back in, the token can weaken. Its price can fall. A subnet cannot just print rewards forever and hope the market will be kind. At some point, it needs to create real economic demand. It needs users. It needs revenue. It needs some mechanism through which actual activity flows back into the token economy. That might happen through buybacks. It might happen through locked collateral. It might happen through usage demand or through fees. But one way or another, the subnet has to start supporting itself. Because if miners are being paid, but no real value is flowing back into the system, then eventually the market will notice. And that is one of the reasons Bittensor is so fascinating. It creates a kind of ongoing evolutionary competition. Subnets do not only compete technically, they also compete economically. They compete for capital, for miners, for relevance, and even for survival. And that brings us to the first example, Bitcast. Bitcast is one of the most unusual subnets in the ecosystem because it does not fit the stereotype people often have in their heads when they hear the word AI subnet. Bitcast is a decentralized creator economy and marketing subnet. In plain English, it is trying to reorganize part of the influencer marketing world. Now, influencer marketing is already a huge industry. Brands want attention, creators have audiences, and in theory that sounds simple. A brand wants promotion, a creator makes content, and everyone is happy. But in practice, it's often messy. There are agencies, middlemen, there's endless negotiating, there's poor measurement, there's a lot of trust-based chaos. And Bitcast is trying to make the system far more programmatic. It is trying to create a platform as a decentralized system where brands define campaign briefs, creators publish YouTube content or X content that satisfies those briefs. Validators check analytics using AI, and the Bittensor network handles on-chain compensation in the subnet's alpha token. Rewarded videos or tweets must satisfy active briefs, and rewards can be based on YouTube Premium revenue stats, for example. So let's make it more concrete. Imagine a company says, we want creators to make videos about a certain product, or a certain ID, or a certain technology. Instead of doing this through a classic ad agency workflow, the campaign can be formalized as a brief. That brief lays out what the content needs to include. Then creators can compete to fulfill it. But what is really interesting is what miners do here. Because in many Bittensor subnets, the miners are running models or serving compute. In Bitcast, the miner role is much closer to the creator side of the marketplace. Bitcast literally describes miners as producing and publishing YouTube content or X content for one or more briefs. The validators are the ones retrieving analytics, verifying engagement, and disbursing rewards. And that is a very different model. The miners are not simply machines solving abstract tasks. They are participants producing media that is meant to generate attention. And that is exactly why I think Bitcast is such a useful example for newcomers to Bittensor. Because it helps people see that Bittensor is not just about optimizing a certain AI model. No. It can also be about coordinating a market around something like attention. What do Bitcast miners actually do in practice? Well, they review campaign briefs, they decide which briefs are worth targeting, they create videos that fit those requirements, and then they publish that content through their YouTube accounts or X accounts. They try to create real engagement, not just clicks, not just nonsense, but actual attention that can be verified. And the validators then play an equally important role. They are not just saying, I like this video, or I don't like this video. They are checking actual performance signals. Bitcast's scoring system is designed to prioritize real engagement and reduce manipulation. So what is the largest significance here? Well, the significance is that Bitcast is effectively trying to turn creator marketing into a more open, measurable, continuously optimized marketplace. Instead of a brand guessing which creator will work, the subnet can discover that over time. Instead of all value being captured by agencies and intermediaries, the network can distribute rewards through a more programmatic mechanism. Now, I want to emphasize something economically important here. Bitcast recently became notable because it publicly said its X incentive mechanism became profitable against minor emissions, with a post claiming it hit profitability only 17 days after launch. And this matters because it suggests real economic activity was already offsetting what the subnet was paying out to miners, at least in that incentive track. And this is a huge concept for listeners to understand. When I say a subnet offsets minor emissions, what I mean is this. Normally, a subnet can feel a bit like a startup that is still paying everybody out of investor money. The rewards are going out, the team is building, the network is functioning, but it is still in subsidy mode. When a subnet starts offsetting those minor emissions with real revenue, something changes. Now, the subnet is not just being held up by emissions. Now it is demonstrating that the outside world is willing to pay for what it does. That's the difference between a system that is merely alive and a system that may actually have discovered a sustainable business model. And if a subnet can become net positive, then in theory it gains a completely different type of strength, because then it is no longer just printing rewards and hoping demand appears later. Now it can potentially support its own economy. It can potentially defend its token by doing buybacks. It can potentially reinvest. It can potentially fund growth from usage instead of from pure inflation. All of this does not mean Bitcast is guaranteed to succeed. Far from it. Creator economies are brutally competitive. Online advertising is brutal. And audience behavior changes constantly. And many things that sound good in theory do not work at scale. But as a proof of concept, Bitcast is fascinating. It shows that a subnet can coordinate something that looks much more like a marketplace around media and attention than a classic AI model competition. And that alone, in my opinion, is worth paying attention to. Now let's move to Hippius, which is another very interesting example of a Bittensor subnet doing more than just AI model improvements. Hippius is building decentralized cloud and storage infrastructure. And this is one of those examples where the use case is easy to understand because almost everybody already uses the centralized version every day. If you upload a file to Dropbox or use a website that stores media in Amazon S3, or depend on centralized cloud hosting for data and applications, you are using storage infrastructure. It's one of the quiet foundations of the internet, and Hippius is trying to build a decentralized version of that kind of infrastructure. And its public materials describe it as offering an all-in-one cloud platform with storage, compute, GPU services. It also says its network of miners scales globally and that everything runs on its own blockchain powered by Bittensor. This is really important because it shifts the imagination. Instead of thinking Bittensor is a place where models answer prompts, think Bittensor could become part of the invisible infrastructure stack that software uses. That's a much bigger idea. So what do Hippius miners actually do? Hippius miners basically provide storage. And Hippius says miner performance is scored on uptime, speed and reliability, with slashing for poor performance or fraud. That means a Hippius miner is not just doing generic computation. A miner may literally be storing your data, serving files, or participating in decentralized cloud-style infrastructure. And this matters because storage is one of the most concrete, boring, real-world digital services imaginable. And I mean boring in a good way. Boring infrastructure is usually the most important infrastructure. People rarely get excited about storage, but websites break without it. Apps break without it. Businesses break without it. So if Bittensor can coordinate something as practical as storage, that says a lot about the kind of economy this network might eventually support. And think about it. Even all the other subnets on Bittensor, they need to store their materials somewhere. If they can do this on another Bittensor subnet, this is huge. Now, Hippius gets especially interesting when you look at the token design. Miners are basically incentivized or obliged to lock up some of the tokens they receive, so some of the Hippius tokens, okay? They have to lock it up for an extended period of time. It also uses a revenue from storage services to buy back its own token and lock it up. And all of this results basically in the price of its subnet token going up. And this is exactly the kind of thing I keep talking about on the podcast when discussing subnet token economics. Because here you can see the team actively trying to design a value flywheel. The more miners contribute and the better they perform, the more subnet token is locked up. The more revenue Hippius generates, the more subnet token is locked up or burned. Meaning the price of the subnet token is going up. So when I say the team is actively trying to design a value flywheel, I don't just mean we have a token because every crypto project needs a token, but rather how do we connect storage usage, collateral locking, reward distribution, and real economic activity in a way that might actually make the token matter? And that's a much more serious question. So let's translate that into human language. If miners need to lock tokenized collateral in order to expand operations, that reduces circulating supply. If usage of the storage service grows, more economic activity flows through the system. If part of that activity feeds shared pools or reward mechanisms, then token holders are not just sitting there praying for hype, they are participating in a system where actual service usage may matter. Oh, and one more thing. Hippius claims its storage is hundreds or even thousands of times cheaper than well-known centralized competitors, which may sound crazy, but have a look at their website if you want to know more about this. Again, all of this does not guarantee success. Storage is hard. Cloud infrastructure is brutally hard. Big centralized players have scale, reliability, and massive customer trust. But this is exactly why Hippius is such a good example. It's not trying to win by being louder, it's trying to win by building infrastructure with an economic design that ties network behavior back to the subnet token. And that is one of the deepest themes in Bittensor. The winners, if there are winners, probably will not be the ones with the best slogans. They will be the ones that manage to build something people actually use, while also making sure that subnet growth flows back into the subnet economy. And Hippius at least appears to be thinking very seriously about that problem. There's another reason I like Hippius as an example for a podcast episode. It helps listeners see that Bittensor could be part of a much broader infrastructure picture. Imagine a future where software developers use decentralized storage the way they now use cloud storage, such as Dropbox. Imagine they do not think much about Bittensor itself, they just want reliable file storage, object storage, maybe hosting, maybe retrieval, maybe compute services. If a subnet like Hippius eventually powers some of that in the background, then Bittensor starts looking less like a niche AI network and more like a foundation for digital infrastructure. So that's the bigger picture here. Now, let's focus on another subnet, which is called Zeus. Zeus is another great example. It is focused on weather prediction. And it might sound surprising at first, because when most people hear about Bittensor, they do not immediately think about forecasting the weather. But that is exactly why Zeus is so interesting. It shows that Bittensor can be used for something much broader, creating open competition around real-world prediction problems. So here's the basic idea. Miners in Zeus build models that try to predict the weather as accurately as possible. Then validators compare those predictions to what actually happens, and the best performing miners get rewarded. So in simple terms, miners are competing to be the most accurate. Now, what makes Zeus especially unique is this. Because there are many independent miners, the network can optimize predictions for very specific places. One miner might focus on one city, another might focus on a particular coastal region, another might specialize in a mountain area where weather patterns are harder to predict. And over time, those miners can adapt their models to the exact conditions of those places, and they can become the expert of that place, which is a very powerful idea, because centralized weather services usually have to build broad systems that work reasonably well across huge areas. But they do not have the time, money, or resources to deeply optimize their models for every small city, town, or tiny region in the world. It's basically impossible for a centralized provider to compete at that level of specialization everywhere. And this is where the power of Bittensor starts to become visible. In theory, you could have miners specializing in extremely specific locations, as long as there's demand for that information. If people want high quality forecasts for a particular city, valley, coastline, or farming region, miners have a reason to focus on exactly that. And if the incentives work, the network could end up producing the best weather models in the world for very specific places. That is something centralized weather providers would struggle to match. So Zeus is not just interesting because it predicts weather. It's interesting because it shows how Bittensor can coordinate many specialists, each competing to become the best at a narrow and useful task. And that is a much bigger idea than weather alone. Now, before we finish this episode, I want to show you one more example. Because so far we have looked at three very different things. Bitcast showed us how Bittensor can coordinate something like a creator marketing marketplace. Hippius showed us how the network might support cloud storage. And Zeus showed us how it can even focus on weather forecasting. But there is another category of digital infrastructure that people rely on every single day, and that is privacy infrastructure. More specifically, tools that allow you to control how your internet traffic is routed and how easily your activity can be traced online. Most people already know the centralized version of this technology, VPN services. And the next subnet I want to talk about is trying to take that ID and rebuild it using the Bittensor model. Instead of one company running servers around the world, imagine a distributed network of nodes competing to provide reliable private routing. That is exactly what TAO Private Network Subnet 65 is attempting to build. The problem it tries to solve is something many people already care about: online privacy. More specifically, it's trying to build a decentralized VPN network. Now, most listeners probably know what a VPN is. A VPN, a virtual private network, allows you to route your internet traffic through another machine somewhere else in the world. Instead of connecting directly to a website from your home IP address, you connect through a remote server. That server then forwards your traffic. So to the outside world, it looks like your request is coming from that server instead of from you. And people use VPNs for many reasons: privacy, security on public Wi-Fi, access to region-restricted services, avoiding tracking, or simply to keep their internet activity from being tied to their real-world identity. But today, most VPN services are highly centralized. You typically pay a company a monthly subscription, your traffic goes through their servers, and that means you are essentially trusting that company not to log your activity, sell your data. And that means you are essentially trusting that company not to log your activity or sell your data. Even if the company claims not to log data, users often have no way to verify that claim. And centralized VPN providers also face another problem. Their servers are often easy to detect and block. Streaming platforms like Netflix, websites, and firewalls frequently maintain lists of known VPN IP addresses. Like the other day, I was watching Netflix and I basically got a message. We detected a VPN service and then I couldn't watch the show anymore. So if you connect through one of those IP ranges, the service may simply refuse access, and this is what happened to me. So the privacy benefit becomes weaker over time, and this is where TAO Private Network becomes very interesting. Instead of relying on a single company running a fleet of servers, TPN tries to build a distributed network of exit nodes. In this model, the miners in the subnet provide the infrastructure. Each miner operates machines that function as network relays or exit nodes. These nodes provide IP addresses through which user traffic can be routed. So instead of a few centralized VPN providers with predictable infrastructure, you get a constantly changing network of independent nodes. And that alone already changes the dynamic. Because if thousands of nodes exist across many different locations and networks, it becomes much harder for websites or services to maintain accurate block lists. The network becomes more fluid, more dynamic, harder to fingerprint. When users connect through the system, their encrypted traffic is routed through those minor nodes. Validators then play an important role in ensuring the quality of the network. They test miners for things like connection reliability, bandwidth capacity, latency, uptime, and routing performance. If a node is unreliable, slow, or frequently offline, it receives lower scores. If a node consistently provides fast and stable connections, it receives higher rewards. So miners compete to provide high-quality network infrastructure. That means running reliable servers, maintaining strong uptime, ensuring bandwidth capacity, and avoiding behaviors that might get their IP addresses quickly blacklisted. So in other words, the subnet creates a competitive marketplace around privacy infrastructure. And this is another example of how Bittensor structure can apply to things far outside the typical AI narrative. This is not about language models. This is about networking. It is about internet routing. It's about privacy infrastructure. And if you zoom out, the potential significance becomes clearer. Because internet privacy tools are becoming increasingly important in a world where more and more online activity is tracked, analyzed, and monetized. At the same time, centralized VPN providers face growing pressure. They are easier to regulate and easier to block. A decentralized network of exit nodes changes that balance. It spreads the routing points across many independent participants. And it creates a competitive system where the best performing nodes receive more rewards. Now again, I want to be careful not to exaggerate, because building a large-scale privacy network is pretty difficult. There are legal challenges, there are abuse risks, there are technical challenges around routing, encryption, and network performance. So TAO Private Network still has a lot to prove. But as a concept, it shows something important again. It shows that Bittensor can coordinate not just models, not just storage, not just forecasting, but also network-level services. And if you start adding these pieces together, storage, compute, data retrieval, privacy routing, you begin to see the outline of something much larger than just AI. You start to see the possibility of a decentralized digital infrastructure stack. Not one company, not one protocol, but a collection of competitive subnets, each specializing in a different part of the digital economy. And TAO Private Network is one small piece of that broader experiment. So now let's step back. What do these 4 subnets reveal when you put them side by side? Well, Bitcast is about attention, media, and creator marketing. Hippius is about storage, cloud, and infrastructure. Zeus is about environmental modeling and weather prediction. And TAO Private Network is about privacy. These are very different domains, and that's precisely the point. The point is not that these 4 are definitely the winners. The point is that these 4 together make it much easier to see Bittensor as something broader than the phrase decentralized AI network might initially suggest. Because what the network is really experimenting with is this: can open competition, continuous measurement, and tokenized incentives coordinate useful work in lots of different categories? That is the deeper idea. And once you see that, Bittensor starts to look less like a single product and more like a framework for organizing digital industries. Some of those industries may be very AI heavy. Some may be partly AI and partly infrastructure. Some may look almost boringly practical. But the common structure is the same. A task exists, miners compete, validators measure, rewards flow, and then the subnet either figures out real economic sustainability or it dies. And that last part matters, because I do not think we should be romantic about the current ecosystem. Again, I suspect most of today's subnets will not survive over the long term. Some will have weak products, some will have weak economics, some will be outcompeted by competitors, some will simply be badly designed, and some will simply not find enough demand. Which is perfectly normal. That's what pioneers are for. Pioneers do not all become empires. A lot of them become cautionary tales. And that, I think, is what you should understand. Do not look at the current subnet ecosystem and assume every name you see today will matter in 5 years. But also do not look at the current subnet ecosystem and dismiss it because many will fail. Those 2 conclusions miss the point. The point is that right now in public, on an open network, people are experimenting with new ways of coordinating storage, media, forecasting, inference, privacy, data retrieval, and many other forms of digital work. That alone is truly remarkable to me. So, that's all for today. Thank you very much for listening to the Discover Bittensor podcast. And as always, if you want more clear and thoughtful content to help you understand Bittensor even more, visit my website, discoverbittensor.com.